Hello dear students, this is Prince, your physics teacher. So today we are going to discuss about the chapter number 8, class 9th, that is motion. Previously we have done the distance and displacement, motion in a straight line. Now first of all recapitulate this, that is distance and displacement. In case of distance and displacement, we already know that the total path covered by an object is called distance. But in case of displacement, we can say that the initial and final position, that is the shortest distance, is called displacement. Suppose we have an example. A person is standing at point A, have to travel from anywhere that he have to reach at point B. Now this actual path is called distance. Number of times its direction is changed, it means it has no any particular direction, it means it is distance. Now if we draw a straight line, here is a particular direction, so it is displacement. In this case only, distance is greater than displacement. Now second case, suppose a person A is standing at point A, move anywhere, or after traveling a distance he again reached to the same point A. Now its initial position and final position both are same. Now if its both positions are same, the total distance covered is distance and the shortest distance is displacement, so it is 0. Then we can say that displacement can be 0. Now what third point is, suppose the same person had to travel from A to B, it's a straight line. Now actual path and shortest distance, that is displacement and distance, both are equal. So with this we can conclude that the displacement is less than or equal to distance. Okay, and we can say that displacement can be 0 if a person is moving in a round path. He reached same point after a fixed interval of time, or after a rotation of after when he completed its rotation. So it means in case of displacement it can be 0 and distance cannot be 0. Distance is greater than and equal to displacement. So next, come to the next topic, that is uniform and non-uniform motion. Now in case of uniform motion, that is if an object travel equal distance in equal interval of time, that is said to be uniform motion. Suppose a clock second hand is moving, completing a one rotation in 60 seconds. It means if we are dividing 360-degree angle of a circle in equal 60 parts, it means one part move in a 1 second. It means total 60 parts travel in 60 seconds. It means this is called uniform motion. So another example, suppose a person is moving on a road with its constant speed, let it is a distance of 10 meter. Now he is traveling with a constant speed, that means we can say that 1 meter in 1 second, next 1 meter again in 1 second, and last 1 meter up to zone, last 1 meter in 1 second. It means if we have to check the motion of a person, that is uniform motion. It means 1 meter in 1 second. Its ratio initially and finally remains same or constant. So it is called uniform motion. Now second, we have a non-uniform motion. Now in case of non-uniform motion, it is just a different from uniform motion. As we know, in case of uniform motion, distance traveled by any object is equal distance in equal interval of time. But in case of non-uniform motion, the distance traveled is not equal to the equal interval of time. Suppose a person driving a car from point A to point B, but here are number of phases, that is maybe there is a traffic a little much, or maybe it's a plain road. Now this driver has to travel from point A to B. He is changing its speed. Sometimes he is applying acceleration, sometimes he is applying a brake. Then number of times its speed decrease or increase. Firstly, suppose it is a 60 km per hour, then it is 40 km per hour, then it's 20, again 60, again 20, and maybe at last it is 80. It means number of times he is changing its speed, number of times its motion with respect to time is changed. It means it has no any fixed motion. That motion is called uniform motion. So next we have speed. Now in case of speed, we have to calculate the distance traveled in particular time. So by defining a speed, we can say that rate of change of distance is called speed. It is represented by V. Now as we know, in case of distance, we can represent distance by S dx. Whatever you feel comfortable, that you can use that word. That is, mostly we are using S for distance, and in case of displacement also it is a S. So to make a formula, speed is equal to distance over time. As we know, that is the rate of change. Rate means time divided by time. It means speed is equal to distance divided by time. Now what are the distance? What are the units of distance? That is meter. What are the units of time? It is second. It means units of speed is meter per second. So simply we can say that SI unit of speed is meter per second. Now next we have average speed. What do you mean by average speed? That is total distance divided by total time taken, or simply we can say that is a ratio of total distance traveled by object in a particular in a total time interval. Okay, now suppose we have to solve some questions related to the speed and average speed. Let a car, that is question, a car is moving from point A to B in 1 hour with 1 hour, where the distance from A to B is 80 km. Find its speed. Now what will be its solution? as we know, in case of speed it is distance divided by time. So here distance is 80 kilometer. We can say that distance is 80 and time is 1 hour. Now its speed is 80 kilometer per hour. These are also a unit of speed. So first of all, suppose we have to convert kilometer per hour into meter per second or meter per second into kilometer per hour. Then we have a relation between kilometer per hour and meter per second. Let's derive relation between kilometer per hour and meter per second. So if we can say that 1 kilometer means 1000 meters. Now in case of 1 hour there are 60 minutes, and in 1 minute it is 60 seconds. So it is 3600 total seconds. Now suppose we have to convert 1 kilometer per hour. What we can do, that is, in case of kilometer, 1000 meters divided by 60 into 60, 3600 seconds. Now this is meter per second. Now cancel these two zeros. It is 518. Now 1 kilometer per hour is equal to 5 by 18 meter per second. Again, by reversing this equation, we can say that 1 meter per second is equal to 18 by 5 kilometer per hour. This relation is mostly used in numericals. So please keep in mind, you have to learn it. Or we can try to solve yourself. Now next we have example related to average speed. In case of average speed, as we know, that is total distance in the short form, that is total distance, total time. Okay, that is average speed. Suppose it is speed, AB means average. Now we have to calculate average speed. Let's do an example. Suppose a person is traveling through a car from city A to B. The distance from A to B is 100 kilometer. Now firstly, he takes a time of 1 hour to reach that point. Then after reaching that point, he is again traveling from B to A. It will take 2 hours. Now we have to find the total distance and total time for average speed. Now firstly we have to find total distance. The total distance is 100 plus 100. I am talking about distance, not a displacement. In case of displacement, its displacement is 0, but in case of distance, he is traveling total distance. It is 100, again came back 100, that is 200 kilometer. Now total time, firstly he cover in 1 hour, then 2 hours, it means 3 hours. It means the total time is 3 hours, total distance is 200 kilometer. Now average speed is equal to, that is 200 divided by 3. It comes approximately, it's approximately 66.66 up to so on 7 something kilometer per hour. That is average speed. So with this we have completed our topic, that is speed and average speed. In next lecture we will do velocity and average velocity. So up to this, please try to do an example number 8.1 given in NCERT textbook. So for any doubt or query, please comment in the comment section. Also you can send me a mail on my email ID that is given below, so that I can solve your problem on timely and come to the next lecture with another video. So stay safe and take care. Thank you.